So our research group is interested in understanding ways in which we can improve bone strength, and horses present a really useful dual benefit model for understanding how exercise in particular can be used as a mechanism for preventing fractures later on.
Equine fractures are a major clinical problem in horses. They happen commonly during racing, training, and other athletic events, and unfortunately tend to happen very often in the public eye, and so they are a major safety and welfare concern. And there's been a lot of research done on different factors that might contribute to fractures in athletes, and those include things like footing and track surfaces and shoeing, but we're trying to look at this from a different perspective, which is how do we prepare our equine athletes better so that they're more resistant to injury once they get into training.
We found in our previous research that exercise when you're young can actually change your bone properties in a way that makes them last lifelong. So what's exciting about this is a collaboration between engineers and clinicians to address these important issues related to bone fractures. And we combine our tools as mechanical engineers to try and develop predictive models that will tell us whether or not a given intervention will actually benefit long-term the overall health of horses. So in this study, what we're doing is actually taking horses when they're quite young, so foals, and at around 8 weeks of age, they begin an 8-week course of exercise. And throughout that time, we take CT scans before and at the end of exercise, and then even later at 6 months and 1 year, because we know remodeling cycles in bone, that is the time that it takes for the cells to activate, to actually lay down new bone, and for that bone to form, takes on the order of months. And so we want to track when that process is happening, even after our exercise intervention is over.
The CT is the way that we evaluate bone most effectively in terms of imaging, and so by taking serial CTs over time, we can see how the bones change in response to both age and growth and exercise. And so we are comparing foals that are in their normal natural environment, turned out in a pasture, compared to those that are undergoing an exercise intervention.
So one of our goals is to actually develop predictive models that tell us whether or not the mechanical stimulus that comes from exercise, which could take the form of something like strain or stress, whether or not that would actually be indicative of an eventual remodeling activity or where new bone would be formed. And so to do this, we need a couple of pieces of information. We need to know what the loading conditions are. So how are the muscles and the joint forces acting on the bone? And for that, we use motion capture, where you put dots on your subject, so in this case the foals, to track their movement patterns, and then we combine this with information that we've previously collected of how much force they're exerting on the ground, essentially. And we use those with rigid body musculoskeletal models to get us estimates of what the muscle forces are during a trot or different gait patterns, and then combine that with another set of models called finite element models. So these FE models, finite element models, are derived from computed tomography or CT data that we actually take of these exact same horses, in which we can convert our CT images into 3D solid models and then use those to actually evaluate what the stresses are, for example, on the bone.
So myokines are basically proteins that are produced by the muscle, and they can act in one of two ways. So they can either act locally on the cells that are close by, or they can go into the bloodstream and act systemically, so they can travel anywhere in the body. And these are like signaling factors. So when the muscle is active, it produces these factors that can then go to other parts of the body and stimulate other tissues like bone to grow. And so by measuring those in the blood, we can determine if part of the reason why bone responds to exercise is because of the activity of the muscles rather than just the biomechanical forces of exercise itself.
I think what's powerful and exciting about this project is that we, through the development of these methods and by working together with a wide variety of collaborators, that we can actually make progress towards predictive understanding of how bone responds to mechanical loads.
Our hope with this study is that we can learn how to build a better athlete from the inside out. So while it's always good to have reactive measures in place where we can make change to things that we have control over, like footing and shoeing, the best way to avoid injuries is to actually prevent them. And hopefully by putting in place appropriate exercise protocols in young horses, we can help to make sure that they're better prepared before they even hit the track. Thank you, Grace and Jockey Club, so much for your support of this project and all of the great work that you do for equine research and health.